In this episode, we step away from predicting labels and focus on a different kind of pattern discovery called association rule mining, which is about finding items or events that tend to occur together. Beginners often hear examples like market basket analysis, where the goal is to learn that people who buy one product often buy another, but the same ideas apply to security logs, web clicks, app behaviors, and any dataset where you can represent activity as sets of things that happened. The key challenge is that association rules can sound obvious or impressive depending on how they are presented, and it is easy to overstate what they mean. A rule like A implies B can feel like a cause and effect statement, but association mining is about correlation in co-occurrence patterns, not about causality or certainty. The goal here is to learn what support, confidence, and lift actually measure, why each one matters, and how to evaluate rules so you avoid being fooled by rules that look strong but are actually unhelpful or misleading. When you do this well, association mining becomes a disciplined way to surface candidate relationships that deserve attention rather than a shortcut to conclusions. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at Cyber.Author.me in the Bare Metal Study Guide series. Association mining starts with a dataset where each record is a transaction, meaning a collection of items that appear together. In shopping, a transaction might be all items purchased in one visit, and in security, it might be all alerts, events, or behaviors observed in one session. From these transactions, we look for frequent item sets, which are combinations of items that occur together often enough to be considered meaningful. Once you have item sets, you can form rules of the form A leads to B, where A and B are sets of items, and the rule is claiming that when A appears, B tends to appear as well. Even at this early stage, you should notice two important ideas. First, transactions ignore order and timing, so association mining captures co-occurrence, not sequences. Second, rules depend heavily on how you define a transaction, because different definitions of what counts as together will change which patterns exist. This means the quality of association rules begins with the data modeling decision, not with the math of the metrics. Support is the first metric to understand, and it answers a simple question. How common is a given item set in the dataset? If an item set appears in 5% of transactions, its support is 0.05. Support matters because rare patterns can be noise, and because rules based on extremely rare item sets can look strong by accident. A rule that fires only a handful of times may not be reliable, even if it looks perfect on those few cases. Support is also a practical control, because the number of possible item combinations can explode as you consider more items, and focusing on higher support item sets keeps the search manageable and the results more stable. However, beginners sometimes set support thresholds too high and miss meaningful patterns, especially in domains where important events are naturally rare. The right mindset is that support is both a relevance filter and a reliability hint. A rule that never occurs is not useful, but a rule that occurs often is not automatically valuable either. Confidence is the next metric, and it is often the one people latch onto because it feels like a probability statement. Confidence for a rule A implies B is the fraction of transactions that contain A that also contain B. If confidence is 0.8, that means 80% of the time when A appears, B also appears. This can be useful, but it is also where many beginners get misled, because confidence does not account for how common B is overall. If B is extremely common in the dataset, then almost any A will have high confidence with B, even if A provides no special information. Imagine a dataset where almost every transaction includes item B. Then confidence will be high for many rules involving B, but those rules are not surprising and not informative. Confidence is also asymmetric, meaning confidence of A implies B is not the same as confidence of B implies A, because the denominators are different. That asymmetry is important when evaluating rules, because a rule may look strong in one direction and weak in the other. So confidence tells you conditional co-occurrence, but by itself it does not tell you whether the rule is interesting or adds value. Lift addresses that weakness by comparing the observed co-occurrence to what you would expect if A and B were independent. Lift for a rule, A implies B is the confidence divided by the overall probability of B, which is support of B. If lift is 1, the rule is no better than chance under independence, meaning A does not change how likely B is. If lift is greater than 1, B is more likely when A occurs than it is overall, which suggests a potentially interesting association. If lift is less than 1, the presence of A actually makes B less likely, which can also be informative. Lift helps you avoid the trap of high confidence driven by a very common consequence item, because it discounts rules where B is common anyway. For beginners, lift is best understood as a surprise factor. It tells you how much A changes the odds of seeing B compared to baseline. However, lift can still be unstable for rare item sets, because small changes in counts can produce big swings, especially when supports are low. These three metrics together form a basic evaluation toolkit, but using them correctly requires you to think about what kind of rule you actually want. If your goal is actionable coverage, you might care about rules that apply to many transactions, which pushes you toward higher support. If your goal is precision, like reducing false alarms, you might care about higher confidence, but only when lift is also meaningfully above 1, so the rule is not trivial. If your goal is discovering surprising connections, lift becomes more central, but you still need enough support to trust the pattern. This is where stakeholder expectations come in again, because different audiences interpret these metrics differently. A non-technical stakeholder might hear 80% confidence and assume the rule is almost always true in a meaningful way, while you know it could simply reflect that the consequence is common. Part of mining associations correctly is learning to translate metric values into plain language claims that are accurate and appropriately cautious. Rule evaluation also includes the idea that rules can be redundant, overlapping, or misleading because of how items relate to each other. If item A and item C almost always occur together, then rules involving A may look similar to rules involving C, creating a flood of near-duplicate findings. Similarly, if B is a subset of A, then a rule A implies B may be trivially true because B is already contained within A by definition. Another common issue is that rules can be artifacts of how items are defined, such as when a broad category item always appears when a specific item appears, leading to obvious rules that do not teach you anything new. Beginners can mistake quantity for insight, thinking that more rules means better analysis, but the opposite is often true. Good association mining is about filtering and prioritizing rules that are both meaningful and usable, not about generating the longest list. Evaluating rules wisely means checking whether a rule is truly new information or just restating a definitional relationship. A major conceptual pitfall is confusing association with causation, which is especially tempting because rules are written in an implication-like format. A implies B does not mean A causes B, and it does not even mean B follows A in time. It only means they appear together often under your transaction definition. This matters because you might see a rule and invent a story about why it must be true, and that story can feel convincing even if the association is driven by a hidden factor. For example, two events might co-occur because both are triggered by the same underlying condition, not because one leads to the other. In security data, you might see a rule that a certain alert co-occurs with a certain user action, but that could be because both happen during normal onboarding flows rather than because one indicates malicious behavior. The correct way to treat a rule is as a hypothesis generator. It suggests a relationship worth investigating, not a conclusion to act on without validation. Mining associations correctly means you resist the urge to narrate beyond the evidence. Another practical challenge is multiple comparisons, which is a fancy way of saying that if you search through enough possible combinations, you will find patterns that look strong by chance. Association mining often explores a huge space of item sets, so even random noise can produce some high confidence or high lift rules. This is why minimum support thresholds exist, but thresholds alone do not solve the problem. You also need to evaluate whether a rule generalizes beyond the dataset you mined, which conceptually means validating it on new or held-out data. Even if you are not doing a full workflow, you can still grasp the idea that rules should be tested for stability. Do they persist over time, across different samples, or across different segments? If a rule only appears in one narrow slice, it may be capturing a temporary or incidental pattern rather than a durable association. For beginners, the key is to remember that data mining can produce convincing-looking coincidences, and your job is to separate durable patterns from random discoveries. To communicate rules responsibly, it helps to frame them with baseline rates and context rather than presenting a single metric. If you say a rule has 0.8 confidence, you should also be able to say how common the consequence is overall, which is what lift relates to, and how often the whole pattern occurs, which is support. You should also be clear about what a transaction means in your dataset, because that defines what together really means. In many applications, the actionability of a rule depends on whether the items are controllable, interpretable, and relevant to the decision. A rule involving obscure or unstable items may not be useful even if it has high lift, because it cannot be reliably detected or acted upon. On the other hand, a moderately strong rule involving well-defined items might be very useful if it supports prioritization or investigation. The responsible communication pattern is to treat metrics as evidence, explain what they imply in plain terms, and avoid implying inevitability or cause. Finally, association mining fits into the CompTIA Data AI certification mindset as a method for discovery that requires careful evaluation and cautious interpretation. Support tells you how often a pattern occurs. Confidence tells you how often the consequence appears when the antecedent appears, and lift tells you whether the rule is genuinely informative beyond baseline. Using these metrics together helps you avoid common traps like trivial high-confidence rules and unstable low-support rules. Evaluating rules also means recognizing redundancy, definitional relationships, and the risk of coincidence when searching many combinations. Most importantly, you learn to treat association rules as starting points for investigation and decision support, not as explanations of why something happens. When you mine associations correctly, you gain a structured way to surface meaningful co-occurrence patterns while maintaining scientific humility about what the patterns can and cannot prove.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.